This is a quick look at overloaded subscript operator, and it's typical to define two of these operators inside containers, with one providing constant access to elements of the container and the other providing a non-constant or constant or mutable access. So this is how you would define your class, and typically your container may be a template class, which is requiring the data type of the elements contained in your container to be specified by the template declaration here. And so this is a non-constant version of the operator, which takes, so this is the name of the function, and this function will be invoked whenever you use the square brackets next to your to the reference of your object, of your container. In this case, we name it myArray. And the other version of this operator, which is used exactly by the source, is constant version of it. So it could return a copy of the element or a constant reference to that element. There could be two variations right here. And so this is an example of an idea of array of elements with two of these overloaded operators. And then we define copy element, and we say, okay, let's copy element specified by the index. And this function takes just my array of integers, and it is expecting to have source object and destination object. So here it's using this right here. Both are my array objects passed by the reference to this function. But because this is on the left-hand side, of course, it will be using a non-constant version of the operator. And this one is on the right-hand side of the assignment, so it does not require mutable access to elements. So it will be using the constant version of the operator. So this is how compiler distinguishing between the non-const and const versions of these operators. So notice also that a non-constant version right here, so this version right here, returns a reference to the element. So of course when compiler sees this subscript operator, it returns back. Let's just sort of like do a demonstration of this. So supposedly this is the source, okay, and it contains some elements in this container, and this is the destination, also another container. They don't have to be the same size, but I'm just drawing it the same size, and say that for example our index is 1, right? So if index is set to 1 by the caller, or here it's set to 0, but let's say that it's set to 1. So index is pointing to this element in both of these containers. So this is our source. So it contains this object right here. So in the source situation, it seems like we're making copy of this element, right? So we're making the copy of this element and returning it from this operator implementation. So we get copy right here. But when we go to the destination, when using this using this version of the operator, it returns a reference. So the reference essentially gives access to the actual content inside of our container. And when we execute the assignment, of course this copy will be used to assign it to the content inside the destination, right? So this is destination, this is the source example. So that's how these two operators work together, that they can be used on both sides, the right hand side and the left hand side, constant version of subscript operator and non-constant version of subscript operator. So here we are using the example of copy element with index 0, but of course this could be indexed to any element, and as long as it's inside the range of both these source and destination containers, everything will be okay, and this is how it works. So like I said, an alternative to this returning a copy could be returning a const, right? Constant element const reference like this, right? We could use const ampersand right here next to the element, and that would not even make any copies. Then we have the source and the destination right here, and they both contain elements at the specific position specified by the index. Essentially, the source will return constant reference to the element right here, and the destination returns non-constant reference to the destination right here. So of course the assignment on this line will just take content from here and assign it to the destination element like this, right? So this is the quick overview, very informal overview of the idea that C++ allows overloading nearly all operators, and subscript notation is recognized as an operator, and it involves basically the object and some kind of integer index, or it could be other data types. You can overload this for strings and use this in a more sophisticated way of providing different types of subscripts for the users. But this is a quick overview how this works, and the subscript operators can be overloaded. And so that's exactly how they overloaded for string class in C++ standard library.